Here we go. All right. So what you see here in front of you is an example of a growth model. Exponential. We call it exponential because we have our friend right here. You see x? He's an exponent. That's why it's an exponential equation. Our variable is in the exponent. Yeah, two main parts of the exponential function. You see this red arrows is c. C represents your horizontal asymptote. What I mean by that is if I draw a little line here, you'll see that this graph doesn't cross this line. And the equation of this line would be y equals c, because y represents a horizontal line. So this graph does not go below that line. And here you see there's another arrow here. This is your, of course, this is y-intercept. This is represented by, the y-intercept x is 0. But what we also know is that the y-intercept, the y value is k plus c. The reason why we know that is because we know that this horizontal asymptote gives us our limit, like our graph cannot go below that. So that means every value has to be bigger than c. And so for our y-intercept, we'll say, okay, whatever this number is, k plus c. And what's an asymptote again? Good question. So I'll draw a little graph. Here's a graph. Let's say this is my graph, and I have an equation or a function that's like this. And it goes like that. Asymptote means it's an imaginary line that the graph never crosses. So as you can see here in this graph, you'll see that our graph doesn't go below that y equals c, that value. So it's saying that's like our limit. That's like the ice. We can't go through the ice because if we go through the ice in the winter, we'll go into the water and we'll drown, and it's so cold we can't breathe. So yeah, we can't pass through that wall, that floor there. And with this graph, we know that k has to be positive, bigger than 0. That's why it's going up like that. It's going like it's flying into the air like Superman to save the day. And our domain here, if I'm going along the x-axis here, both ways, you'll see that the graph is covering all the x values. Some people like to write this, all real numbers. Or in this form, they'll say let's go from negative infinity to positive infinity. Can I go over k, x, and a? Yes. So k is your multiplier. So for example, if I have an equation that looks like this, 2, 3 to the x plus c like that, or I'll make that a number. I'll say that's 8. So in this equation here, my k is 2, my a is 3, and my c is 8, which means this is my horizontal asymptote. This k will tell me what my y-intercept is because it'll be 0, and then 2 plus 8, which will give me 10, my y-intercept. Then the a is just part of your exponential function. It's just saying 3 to some power of x. And then here it's just saying when you have an exponential equation, a cannot equal 1, k cannot equal 0, which we'll never have 1 or 0 for this function. And then what this means here is our a has to be a rational number. All that means is the number that's going to be there for a is always going to be something that can be changed to a fraction. So rationally, you might see it as a over b. Just saying it can be written as a fraction. So for example, 1 can be written as 5 over 5. 1 can be, I'll write that 5 over 5. 2 can be 4 over 2. Any number that can be written as a fraction is rational. Now back to this. So we got the domain. The range would be, okay, we want to look at, move this out of the way. We want to look at the height of the graph. So where does it start and where does it stop? Let me use, I think this is probably my favorite color. Actually, I don't know what color this is. So I'm looking at the height of the graph. Where does it start? Where does it stop? So here, that's magenta. What is that? Morado? Yeah, magenta. So it goes up like this, but as you can see, the graph goes up to infinity. So it keeps going up and up and up, but then it stops right here. So for a range, the smallest value would be C, and the biggest value is, oh, it goes up to infinity. And then for my behavior, we'll say as x goes to infinity, so if we're going this way, what happens to our y values? Oh, y values go to infinity. And then we go the other way, as x goes to negative infinity, so it's going this way. You notice the graph is going down like that, but it's following this horizontal asymptote here, and it's never going to cross that. So y is approaching C. So y is getting closer and closer to C. Right here, this next one, it's still a growth model because we say it's a growth model because of this. This is growth because this is positive. Now again, C, same thing. This is our horizontal asymptote. So I'll draw a little. This is y equals C. Because we're saying that this right here is their C value right there. Now domain, if you notice our domain, so for exponential functions, our domain is going to be negative infinity to infinity, or all real numbers. Because if you notice here, it's still covering every value on the x-axis. There's always an x value for each point on the graph. Here we go. And then for our range, so the height, notice, so it's going from C here all the way down to negative infinity. So we always start with the lowest value. So negative infinity, and then it stops at C. For my end behavior, as x goes to positive infinity, we're going this way. Oh, look, my graph is going down like that. That means y is going down to negative infinity. And then as x goes the other way, negative infinity, this way, you see that? Now y is approaching C. So it's the same thing as the other one, except now they're flipped because it's going down. And also last thing, y-intercept. This never changes, k plus C. So decay model, only different thing is this. So you see it's negative. Negative means decay when your x is negative, but everything else stays the same. That's also your horizontal asymptote. There is our y-intercept, same thing, 0, k plus C. C would be right here. So that's y equals C. The only difference now is that now our graph is going down like that because it's decaying. But again, if you notice, for our domain, it's still covering all values of x. It's wide. So it's from negative infinity to infinity. And then for my range, again, the height. So notice the graph is stopping here. It doesn't go below this. So that's the lowest point on the y-axis. So the lowest point is C, and then the highest point is it goes all the way up to infinity. And behavior, again, this is very, very similar. As x goes to positive infinity, you'll notice that the graph is coming down, 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 closer to C. So y is C. As x goes the other way to negative infinity, this way, you notice the graph is going up. So my y values are going all the way up in the air. So y goes to positive infinity. So if you notice here, k is positive. Well, what happens when k is negative? It's flipped over the axis. Same exact graph, just flipped over the axis, just like the last one. You see it's flipped over the x-axis. And it's flipped because you'll see this is still, so this is still negative, so it's decay. This is still our horizontal asymptote. So again, C would be right here. So y equals C. This is still our y-intercept. Still gonna be 0, k plus C. Only difference is now this is negative, which means it's below the x-axis. So then you can say the domain again, that doesn't change because it's exponential. It's covering all those x values. Our range now with the height, so it goes from here to infinity. So it's always going to be from small to big. So negative infinity, then it stops. It goes stops at C. And behavior, it's going to be x approaches infinity. So we're going this way. The graph slowly approaches C. So y approaches C. As x goes this way to negative infinity, y goes all the way down to negative infinity. You know, our end behavior is always going to be the same. It's always going to be y approaches C or y approaches negative infinity. It just might get switched around depending on which way your graph goes.